We now discuss the solution of a problem from the section Algebra. The problem is related to linear congruences from the subsection Number Theory of the section Algebra. This question has appeared in the CSIR National Eligibility Test held on 16th September 2022, and the problem is from the section C. The given question is, let a comma b be positive integers with a greater than b and a plus b is equal to 24. Suppose that the following congruences have a common integer solution. 2x is congruent to 3a mod 5, x is congruent to 4b mod 5. Which of the following statements are true? Options. Option 1, 10 less than or equal to a minus b less than or equal to 20. Option 2, 3b greater than a greater than 2b. Option 3, a greater than 3b. Option 4, a minus b is divisible by 5. We have two positive integers a and b with the properties a is greater than b and a plus b is equal to 24. We are given two congruences, and it is given these two congruences have a common integer solution. These are the two congruences given here. And now which of the given four statements are true? It is a problem from the section C, therefore it can have more than one answer, and you have to find out all the true statements. We now discuss the solution of the problem in detail. We are given a comma b, both are natural numbers, that is positive integers, a greater than b and a plus b is equal to 24. We are given two congruences, and that is 2x is congruent to 3a mod 5 and x is congruent to 4b mod 5, and it is given that these two congruences have a common integer solution. Agreed. Now 2x is congruent to 3a mod 5. We take this and pre-multiply both sides by the inverse of 2 modulo 5. That is, this implies 2 inverse multiplied by 2x is equal to 2 inverse multiplied by 3a. And this will give you x is congruent to 2 inverse modulo 5 is 3. So x is congruent to 3 into 3a modulo 5. And 9, 3 into 3 is 9. 9 modulo 5 is 4. Thus we get x is congruent to 4a mod 5. Thus we have x is congruent to 4a mod 5, and we already have x is congruent to 4b mod 5. From these two, what we get is, this will imply 4a is congruent to 4b mod 5. Use the transitivity. Now multiply both sides by 4 inverse, then you will get a is congruent to b mod 5. That is, a minus b is congruent to 0 mod 5. That is, a minus b is a multiple of 5. 5m, where m is a natural number, because a greater than b, a plus b is 24. So a greater than b means a minus b is positive. Therefore, 5 times m, where m is a natural number. M is a natural number. This implies a minus b is divisible by 5. Now let's recall one of the options. The option is option 4. A minus b is divisible by 5. We got it. Therefore, the option 4 is true. we continue the discussion in the next slide. That's what we have so far. Let A minus B. Now, A minus B is a multiple of 5, that is 5 times m belongs to n. This is that. So 5 times of a natural number. First we consider odd ones, 2k minus 1, where k belongs to n. Now we have A plus B is 24. A minus B is equal to 5 times 2k minus 1, k belongs to n. So from 1 and 2, adding these two, we get minus b plus b goes off, and 2a is equal to 24 plus 5 times 2k minus 1. Now 2 divides 24, but 2 does not divide 5, and 2 doesn't divide 2k minus 1 also, because 2k minus 1 is odd. So therefore 2 does not divide 24 plus 5 times 2k minus 1. Thus A finds no solution in n. So we consider therefore A minus B is equal to 5 times 2k even. The odd one is discarded now. So 2k. So now call it as the equation 3, and adding 1 and 3, we get 2a is equal to 24 for plus 5 2k. So 2 divides 12, 2 divides 2k also. Therefore a is equal to 12 plus 5k. When a is equal to 12 plus 5k and a plus b is equal to 24, then b is equal to 24 minus a, and that will give rise to 24. B is equal to 12 minus 5k. A is equal to 12 plus 5k and b is equal to 12 minus 5k, where k is a natural number. Suppose you take k is equal to 1, then a minus b is 5 times to 10, and a will be 12 plus 5 17, b will be 12 minus 5 7. Therefore a comma b is equal to 17 comma 7. When k is equal to 2, it will be a minus b is equal to 5 into 2 into 2, 4. 4 5s are 20. And when k is equal to 2, you get 12 plus 2 times 5, that is 10, that is 22. And b will be 12 minus 5 into 2, that is 12 minus 10, that is 2. So we get a comma b is equal to 22 comma 2. Now suppose you take k is equal to 3. So you will get b value 12 minus b times 3, 15. 12 minus 15, that means b is negative. And so also for k is equal to 4, and so on so forth. So that means for all k greater than or equal to 3, b is negative. But b belongs to n, therefore we cannot consider all those. So note that b is negative for all k greater than or equal to 3. So these are the only two possible answers what we are waiting. Thus the only possible values for a comma b is 17 comma 7, and a comma b is equal to 22 comma 2, and a minus b is equal to 10, and a minus b is equal to 20. Agreed. We continue for the further discussion. That's what we have done so far. Let's call the option 1. 10 less than or equal to a minus b less than or equal to 20. This statement is true because a minus b is 10 is satisfied, and a minus b is equal to 20 is satisfied. So therefore the option 1 is true. Let's call the option 2. In the option 2, for the first solution, 3b is 3 7s are 21 greater than a, that is 17, which is not true. For the second solution, 3b 3 2s are 6 is greater than 22. This is also not true. So therefore this inequality is not true for both the solutions. Right. Therefore, the option 2 is not true. Now, option 3, a greater than 3b. And if I take the first one, 17, 7, a 17 greater than 3 times 7, 21 is not true. So this inequality is not true for a comma b is equal to 17, 7. Therefore, the option 3 is not true. This is not 2, this is 3. Option 3, there is a typographical error. Option 3 is not true. Anyway, now the answer to this question is options 1 and 4. Option 1 here, 4 in the last slide, and both are true. So that is the detailed discussion of the solution of the problem from the section Algebra, and the problem is on linear congruences from the subsection number theory of the algebra. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.